Hello everyone, my name is Brankica Supica and this is my learning object for DL5203, Digital Content for Learning. My learning object is based around the electromagnetic spectrum. This presentation and learning object is intended for a 7th grade science class and curriculum. So let's begin. The electromagnetic spectrum. Well, first we need to figure out what is the electromagnetic spectrum. The electromagnetic spectrum is radiation that is organized by the amounts of energy a wave gives off. Those are broken down into radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. When we talk about radiation, we need to know a few things about radiation, like for instance, where it comes from and what it does. Radiation is the movement of energy throughout outer space. All of the different types of electromagnetic spectrum waves move at a different speed, and that all depends on how their photons work. Well, what is a photon and what does a photon have to do with it? Well, a photon is the stream of electromagnetic particles that travel throughout a wave. Depending on how fast or slow these photons move depend on the type of wave it is. Before we move on and talk about the 7 different types of waves that are located on the electromagnetic spectrum, let's take a minute to stop and reflect about what we just talked about. Now as a group we're going to review. The first thing I want you to think about is, what is the electromagnetic spectrum and how is it organized? Let's go back to radiation and think about where radiation moves through. And lastly, let's refresh our memories and think about how do photons work and what effect do they have on waves. Great job. Let's move on. There are 7 different types of waves that can be located on the electromagnetic spectrum. The first one we have are radio waves. The next one we're going to talk about is microwaves. Then let's talk about infrared light. We also have visible light, ultraviolet rays, X-rays, and lastly, gamma rays. Once again, before we get more in depth about each individual wave, let's stop and think about what are the 7 waves that we just talked about. Great job. Let's move on. The first wave we're going to talk about is radio waves. Well, radio waves are the lowest wave strength on the electromagnetic spectrum. A lot of us are pretty familiar with radio waves, seeing as though they are the waves that transport AM and FM signals to our radios. We also can't forget about TV waves. Radio waves transport the information we need to watch our favorite TV shows. And we can't forget our good old cell phone. Cell phone waves are also transmitted by the radio wave. Next one is microwaves. Microwaves are the second lowest wave strength on the electromagnetic spectrum. They also power our microwaves, which cook our favorite meals, and also plane radar systems, which allow planes to fly and land safely. Then we have infrared light. Infrared light produces heat through different sorts of pictures. We can't see infrared light, but we can definitely feel it. There's also a lot of different infrared light that we don't know about but use on a daily basis, like our remote controls to turn on our TVs and also turn on our favorite DVD players or Blu-ray players. Let's stop and think again. Let's reflect and see what we can remember. Alright, let's go back and start thinking about radio waves again. Are radio waves the strongest or the weakest wave on the electromagnetic spectrum? Second question. What are the 2 instruments that we talked about that use microwaves? And our last question is a true or false question. Infrared light can be seen but not felt. Great job. Let's move on to the fourth wave on the electromagnetic spectrum. The fourth wave is called visible light. Visible light is broken down into the different colors that we are accustomed to seeing: red, orange, yellow, green, indigo, blue, and violet. In order for us to see visible light, we need the cones in our eyes to help us. Well, cones help people to see the wavelengths of light to produce different colors. Without the cones in our eyes, we wouldn't be able to see all of the beautiful colors that are out there. Next up is ultraviolet light, usually known as UV rays. Many of us, if we've gone tanning, we sure know what that is. And UV rays come from the natural waves from sunlight. So if the sun is producing UVA waves, it's hitting the surface, while UVB rays are hitting the water. The ozone layer protects us from the very, very strong energy that is produced from ultraviolet rays. Let's take another minute to stop and reflect about what we just talked about. What allows humans to see different colors? Where does ultraviolet light come from? Excellent work. Let's move on. Now we're going to discuss X-rays. X-rays are probably something that you have heard about before. X-rays are a high penetrating power ray that can go through your body. Doctors only use it in small doses because it is really powerful. And it's used to travel through your flesh easily. That's why you can see the bones, but you can't see anything else. And the most powerful ray on the electromagnetic spectrum are gamma rays. Gamma rays are the most energetic waves on the spectrum. They come from outer space, but are usually absorbed by Earth's surface, so they can't harm us. But if they did come anywhere close to us, they could be deathly. Let's stop and reflect once again. Where do X-rays get used the most? What could gamma rays do to a human? Great job. Let's move on. One of the most important things we have to remember is that the higher the energy level in a wave, the more things it can pass through. So if you noticed, radio waves are the weakest and gamma rays are the strongest. Gamma rays could possibly hurt us or kill us while radio waves are traveling around us all the time. I know we've talked about a lot today, but let's get a little help from our friends. Tim and Moby have a few words for us.
Chicken mushroom. Dear Tim and Moby, what is the electromagnetic spectrum? Signed, Winston. The electromagnetic spectrum is just the name for a bunch of types of radiation, organized by the amounts of energy they carry. No, it doesn't have to be from radioactive material like plutonium necessarily. Radiation is any movement of energy through space. You can think of this radiation as a wave made up of moving electrical and magnetic fields, or you can think of it as a stream of particles called photons. EM radiation is kind of indecisive. Sometimes it behaves like a wave, sometimes like particles. Starting with the lowest energy level, the 7 types of EM radiation are radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. Radio waves are used to transmit radio and television signals. AM radio uses low energy waves, FM radio uses medium energy waves, and TV uses high energy waves. Cell phones use radio waves too, and stars in space can also emit radio waves. Microwaves are used in microwave ovens and airplane radar systems. In the oven, microwaves heat up the water molecules in your food. With radar, microwaves are reflected off an airplane and sent back to the radar system to pinpoint the exact location of the plane. Infrared rays are often produced when an object radiates heat. You can't see them, but you do feel them. A remote control uses infrared rays to send signals to your TV set, stereo, or DVD player. Infrared radiation can also be used to take special photographs called thermographs. The next type of radiation in the spectrum is visible light. Thanks to special cells called cones, our eyes can perceive wavelengths of visible light as color. In order from lowest to highest energy, the colors are known as red, orange, yellow, green, blue, indigo, and violet. Ultraviolet rays occur naturally in sunlight. Fortunately, the ozone layer blocks most UV radiation from reaching the surface of the Earth. In large doses, UV rays can cause skin cancer and cataracts. X-rays have a very high penetrating power. That means they can travel easily through just about anything. Doctors use small doses of them to make pictures of your bones and organs and stuff. The X-rays travel more easily through flesh than bone. That's why shining X-rays through someone onto sensitive film can make an image of your insides. Gamma rays are the most energetic waves in the EM spectrum. Most gamma rays coming from space are absorbed by our atmosphere. But gamma rays are also produced on Earth in high-energy reactions, such as nuclear explosions. Gamma rays do a lot of damage when they pass through living cells. Where does the radiation come from? Well, all matter is made up of atoms, and each atom is made up of protons, neutrons, and electrons. Electrons orbit around the proton and neutron nucleus at different levels, or shells, depending on how much energy they have. Sometimes an electron drops from one energy level to another, giving off energy in the form of electromagnetic radiation. The Sun, Earth, and stars all radiate electromagnetic energy of varying strengths. All electromagnetic radiation moves through the universe at a constant speed of 300,000 kilometers per second. EM radiation can even travel through the empty vacuum of outer space. The higher the energy of the wave, the more stuff it tends to pass through. Ugh, my soup's cold. Thanks. I was kind of afraid you were going to nuke it. No, I meant literally.
I sure love Tim and Moby. They're so helpful and full of knowledge. Let's now stop and think about what we saw in the Tim and Moby clip from BrainPop. Radio waves come in AM, FM, and TV waves. Which one is the highest wave strength? Next question I want you to think about is, what blocks out the UV radiation? Third question, is it safe for doctors to use large doses of X-rays? Please finish this statement. Gamma rays are absorbed by the Earth's blank. And the last question I want you to think about is, what are atoms made up of? I hope through this presentation you have learned to understand about the different electromagnetic waves on the spectrum. And thank you for viewing my presentation and learning object for the electromagnetic spectrum, which was geared towards a 7th grade audience in a 7th grade science class.